Hello, chemistry students. Before we get started today, I'd like to tell a little story. You all know how I like to tell stories all the time. Well, Walmart has started some online shopping where you can place grocery orders and get it delivered, or not delivered to your house, but they'll bring it right out to your car so you don't have to get out. So in this time of crisis, we're good here at the house, but Seth, who's at Fort Benning, was running just a little bit low on some stuff, and so I placed an order for him, and what I ordered him was some cans of pork and beans like this right here. And well, it turns out that apparently I'm not that good at ordering, because what came in was these. So my advice to you is to be careful what you're ordering, or you might end up accidentally getting a little bit more pork and beans than you planned on. Today we're going to continue. We're basically having a blended. Chapters 7, 8, and 9 are kind of blended into one thing. They're all about ionic covalent compounds and naming them and writing the formulas for them. And we're trying to get ready to move into chemical equations and formulas, which will be coming up very soon. So this week we're going to focus on nomenclature, which is naming compounds. And so here is a short little presentation on ionic nomenclature. Later on in the week you will get covalent nomenclature, and then towards the end of the week we'll do another part on ionic, which is ionic of polyatomic ions. Nomenclature. Today we're going to be starting a 3-part video series on nomenclature. Nomenclature is simply a process for naming substances in chemistry, or actually technically in any scientific field. For us, we're going to be doing ionic compounds first, so that is today's lesson. Before we begin that, let's get a couple of real quick definitions. Number 1, a binary compound. Binary compounds are composed of 2 types of elements, or 2 different types of atoms. It doesn't necessarily have to be only 2 atoms involved, but there can only be 2 substances involved in a binary substance. We'll be doing binary ionic compounds. We'll be doing that today. Tomorrow we will be doing binary covalent compounds, and then on Wednesday we'll be doing a 3rd lesson on a very specific type of binary ionic compound, which is the binary ionic compounds containing polyatomic ions. So let's begin with the first basic general idea of ionic compounds. First off is ionic compounds always contain a positive cation and a negative anion. As you remember from class, the positive ions come from the left side of the periodic table, and this group 3 here, and the negative ions come from the right side of the periodic table. As we noted in class, we have +1, +2, +3, except for boron, no charge on that one. And then it's -1, -2, -3, and then once we get in here to carbon, this is where carbon is, we get into carbon, again, no charge. For the first type that we're going to look at today, we're going to look at 2 different slight variations today. For the first type, we're looking at the metals that form only 1 cation. That's going to be the group 1, group 2, and group 3. And then in just a little bit, we're going to look at these transition metals, which are have some slightly different variations on the rules. Type 1 compounds, again, this name type 1 is not important to you. You just need to recognize them as the things that come from group 1, group 2, group 3, which again, as I mentioned a second ago, on the periodic table, that's going to be the stuff. Let's get a little drawing here going. That's going to be group 1, group 2, and group 3 right here, everything except for boron, leaving out again the transition metals. Typical example of a metal and a nonmetal, the classic chemistry example is, what do I get when I mix sodium, which is a Na+1, with chlorine, which is a Cl-1? Well, we use the crisscross method. We drop the 1 there, and we end up with NaCl. For another example, let's take a look at calcium and bromide. Well, calcium, if we look on the periodic table, is a Ca+2. Bromine is, again, a Br-1. When we crisscross this, I get a 1 there, a 2 there, and end up with CaBr2. Calcium bromide. And the final example is we take a look at aluminum. Now, aluminum is a +3, Al+3, and oxygen is a O-2. Again, you just get those from where they are on the periodic table. When I crisscross these, I end up with a 3 there, a 2 there, and that's what you see in the formula right here, aluminum oxide. These are the typical charges. Again, you don't have to worry about this chart because y'all are all very, very familiar with the periodic table. You also have a periodic table of ions in your possession, which gives you all of the charges, but you know it's +1, +2, skip the transition metals, +3, except for boron, and then -1, -2, -3. Again, we leave off the noble gases, and we leave off the carbon group here. We just let it go because no charge on those either. So let's take a look at the general rules for naming ionic compounds that involve group 1, group 2, group 3 cations with any of the anions. Number 1, the cation, the positive ion, is always named first. Don't forget that. The anion always comes second. Number 2, the cation is just named like an element. And number 3, we add "-ide" to the root of the anion. So again, typical example, aluminum. Aluminum is a +3. We call it aluminum. Chlorine, when it becomes an ion, we call it chloride. And so this AlCl3 is called aluminum chloride. Take a look at these 3 examples. What I'd like you to do is I would like you to pause the video, answer the 3 questions, and then start it back up. Okay, the answers for these 3, again, these are all very straightforward. Hopefully you found all these exceptionally easy. We have potassium chloride, magnesium bromide, and calcium oxide. Again, naming them for the element the element potassium, the ion chloride, magnesium, the ion bromide, the element calcium, the ion oxide. And problem number 2 I'd like you to take a look at. What is the name of SrBr2? Once again, pause the video for a moment, answer the question, and then start it back up. Well, obviously Sr, if we remember from our discussion of the names, is strontium, and this is Br, so it's just strontium bromide. Strontium bromide. Now we have to deal with a slight variation, and that is what the text calls type 2, or the transition metal ionic substances. And the trick with these transition metals is they have more than one positive charge. Now we're going to look at the periodic table of ions in just a moment. Y'all have a copy of it, but just keep in mind that several of these in here have more than one charge. And if they have more than one charge, we have to account for that different charge in the name. And what we use to account for that is Roman numerals. So when you look at the periodic table, let's just take a look at that real quick. Here is a periodic table of ions. Everyone should have a copy of this. I gave it out to you the last day we were in class together. I have also posted it in Google Classroom under Chapter 7. But when you look in the transition metals here, and some of these you can actually transfer over, you look in this area, you find a bunch of these have more than one charge. Well, whenever we're naming any of these, we'll use iron as our typical example. We have a Fe, either it's Fe+3 or it's Fe+2. When we name it, we have to account for that in the name. So it's going to, oops, let me go back, sorry. We have to account for that in the name, which is going to be iron 3 if it's a +3, or iron 2 if it's a +2. And all these are the same way. You can see right here under nickel, you can see it's nickel 2 or nickel 3. If I slide down to gold, it's either gold 3 or gold 1. Now, one little caution I want to give you is to make sure you realize that this is not an all-inclusive list. There are charges which are not listed there. This list of ions is just the typical charges. So if you run into an example outside of class, if you're looking at another video, they might have a charge of, there may be an iron 4 out there. Realize that's possible. Every example that I give you in class and every problem that will work will fit on this chart, but just know there are others out there, so don't freak out. Take a look at a couple of examples. If I have iron mixing with bromine, iron has 2 oxidation states, iron 3 or iron 2. If it is iron 3, that's going to be Fe+3 Br minus 1, crisscross it, 1 there, 3 there, and we end up with Fe Br3. That is called iron 3 bromide. You've got to include the Roman numeral. If I have iron 2 bromide, that's going to be Fe with a plus 2 charge, and bromine with a minus 1 still. Crisscross again, I end up with Fe Br2, and that is iron 2 bromide. Now, just as a side note, in case you run into it out there, there is an older system of naming which uses ic and us. We won't use that, but you can see that it can be called ferrous or ferric bromide. Again, just if you run into that down the road, that's just the old school system. We're talking old school, I mean, 60s and 50s and earlier than that, but we've now since then transferred to Roman numerals, so that's what we'll use in class. The rules for naming type 2 ionic compounds are almost exactly the same as type 1. Again, the cation comes first, the anion second. The big difference here is we've got to include Roman numerals on the cation if the cation has more than one charge. So again, if I'm naming this substance right here, I need to look at it and realize that this 3, if I were to crisscross it, Fe and O, if I were to crisscross, there's a 3 there and a 2 there, then that 3 came from the iron, so it's iron 3. That 2 came from the oxygen, so we don't have to put a 2 on that because oxygen is always a 2. And so the name of this is iron 3 oxide. So when we're naming these, we have to include that Roman numeral. That's the only thing that you really need to pay attention to. Now, once again, just taking a look at this periodic table of ions, any of these in this area that have 2 different charges, whenever you name them, you've got to include Roman numerals. So when we're naming stuff, make sure you have this periodic table of ions out. Double check. First thing you should do is you should look at the periodic table and see, are there more than one charge? If there is, make sure you include a Roman numeral. Here are 3 examples for you. I would like you to pause the video, try and name these 3. I will go ahead and tell you all 3 of these require a Roman numeral. Make sure you get the right Roman numeral. Once you have these named, restart the video and we'll check your answers. Okay, here we go. So the first one is copper and bromine. So we know it's going to be copper bromide, but when we go back here real quick, we look at copper. It's either copper 2, Cu plus 2, or Cu plus 1. Well, we know bromide is a negative 1, and copper is either copper 2 or it's copper 1. Well, if I just do both of them, I crisscross it 1 to 1 or 1 to 2, that'd be CuBr2 or CuBr1, CuBr. Well, which one is that? Well, that's just CuBr, so it's copper bromide. And the name of that is copper 1 bromide because it's a plus 1. Do the same thing for the iron, and sulfur is a negative 2. We will find that that is iron 2 sulfide. And we do the same thing for the lead. Now the lead can either be a 2, so it's either going to be lead Pb plus 2, oxygen negative 2, that's lead 2, or it's going to be lead 4, which is Pb plus 4O negative 2. When I crisscross this one, I get 2 to 2, which reduces to 1 to 1. That would be PbO. Well, that's not PbO. So when I crisscross this one, I get a 4 there and a 2 there. That's a 2 to 4 ratio. I'm going to scooch this up here. That's a 2 to 4 ratio. That'd be a 1 to 2 when I reduce it. Well, that's what that is. So this is lead 4 oxide. Now, we may need some more practice on that. Don't worry, I can send some more out for you to look at those. Once again, let's see if you can do this problem here. We're going to name CrO2. Pause the video. Once you have the name, start the video up again. And the correct name is not chromium dioxide. It's not chromium oxide because chromium is one of those on the periodic table of ions that has 2 oxidation states. We need to think again in terms of reverse crisscrossing. If I have CrO2, I bring up the 2 there and a 1 there. Well, oxygen is not a 1. Oxygen is a 2. So I have to double that. I have to double this. So I know the correct answer has got to be chromium 4 to keep the ratio 2 to 1 ratio, which I have here, has to match a 4 to 2 ratio, which makes it chromium 4. And last but not least, I want you to name this one. Now, this is a little tricky one here. We have the ion of sulfur, so we know it's going to be a sulfide. We can already see that in all the answers. And a metal that contains 24 electrons. Once again, this one may take you a few minutes to think about, but I want you to check all these and see which one of these has 24 electrons. Pause the video. When you think you have it, start it back up again. Now, this one's a little tough, but when we look at all the options, iron normally has 26, so iron 2 would have 24 electrons because a +2 charge loses 2 electrons. We end up with 24 electrons, and the correct answer is iron 2 sulfide. Okay, that's going to be the end of part 1, and a little preview. Part 2 is going to be a discussion of covalent compounds. You can look for that video tomorrow. I hope that explained what you need to know about the basics of naming simple ionic substances. There is a practice sheet posted as well. You don't have to turn that in, but I have the practice problems plus the solutions on the page, so you can double check yourself and make sure you're good to go there. Before I let you go, I do want to make mention of one thing, and that is, where is beaker? I received a notification from a student in my physics class saying that where is beaker was filling up their stream with too much stuff, and so I've decided to move Where is Beaker into the videos. Where is Beaker is just for fun. You don't have to participate. I thought it would give something light and entertaining for you to do. But if you wait till the video is completely over, right at the very end of each video that I post, I'm going to put a little Where is Beaker, and on the acknowledgement form you can put in your guess or put in your answer for where you think beaker is during the video. You can look forward to many more videos as we go through this crisis. I think we'll be spending a little bit more time with video learning. Be safe, and I hope to see you soon. Thank you.